Okay. Okay, this is the video for Unit 2, Workbook 7. We are talking about reflectional symmetry. And if you're looking at this butterfly, if we were to draw a line down here and then fold that in half, notice that each half of that butterfly would be the same thing. We would say that this has a reflectional symmetry, and that line that you drew would be the line of symmetry. And then you could say like this I right here corresponds or coincides with this I over here, or coordinates with that one. So those are the main things you need to know for reflectional symmetry is line of symmetry. If we have this trapezoid, there's only one place we could possibly draw a line to have it be the same thing. If we were to fold it across this line, it would look like that, and they would be exactly on top of each other. That would be reflectional symmetry. A rectangle, if we folded it vertically or horizontally, would have reflectional symmetry, but if we folded it on the diagonal, it would not going to line up. So there's only two lines of symmetry. Next thing you need to know are what regular polygons are. Regular means they have the same, like, even number of sides. I mean, like, all the sides are the same length and all the angles are the same. And if it is a regular polygon, then there's this cool thing that says that that's the number of sides it has is the number of lines of symmetry. So right here, notice that this pentagon, so 5 sides, has 5 lines of symmetry. 1, 2, 3, 4, 5. Or this hexagon has 6. All right, so then I'm going to do these checks on them, on both of this unit and the next unit, and then, or the next workbook, and then leave the checkpoint for you to do. So if we look at this thing, so this has 1, 2, 3, 4, 5, 6, 7 sides. So there should be 7 lines of symmetry. Let's just check. There's A, that one's B, that one's C, that one's D, that one's E, that one's F, that one's G. So there are 7 lines of symmetry. And which one of those does that? The only one that has all 7 of them. So there you go. And here's for 7.2, rotational symmetry. If I were to take this thing, looks like a spinner, right? And if I were to actually spin this, it would go back to and look like the exact same thing. In fact, if I spun this side so it goes over to here, then all of them would go around and it would look like the exact same shape. In fact, because there were 3 of them, and one full circle is 360 degrees. If we did 360 divided by 3, that would tell us exactly how many degrees we'd have to turn it in order for it to look like the exact same thing. So 360 divided by 3 is 120. So that would have a 120 degree symmetry. Next thing you need to know is the center of symmetry is the center of that thing. And then how many degrees we turned it was the angle of rotational symmetry. So if we had a parallelogram, and like what it told us what it is, the only way for this to look like exactly like it was is if we rotated this around so that this point over here went over there, it would look like the exact same thing. It has one line, it could only rotate once around, and that is 180 degrees. Trapezoids, the only way to get this to go back into the exact same thing is if I rotate it all the way around, or 360. So we say it does not have rotational symmetry. For regular polygons, then we take the number of sides and divide it by do 360 divided by that. So 360 divided by 4 for a square would be 90, or 360 divided by 5 would be 72 for a pentagon. So you take 360 and divide it by the number of sides, and you'll get how many degrees it would turn. All right. And then any multiply, like if you turn this thing 72 degrees, it would be the same. Or 72 times 2 is 144. It would be the same. 72 times 3, I don't know what that is off the top of my head. I think 126 or 226. It would be the same thing, but I think I did that wrong. Anyway, you get the idea. So then we come down here to the problems that we're going to do on it. 2 whole problems. And which of the following transformations map this onto itself? So let's see. If I reflected it across the x-axis, folded it right here, yeah, it's going to be the same thing. Oh, wait, is it going to be the same thing? Yeah, it's going to be the same thing. It's still going to be a square. 45 degrees is like a diagonal. It would put it at a diagonal. Can't be that. 180 would just flip it around all the way, be the same thing. 90, since it's a square, would go back up to the same thing. If we reflected across this diagonal line right there, because it's a square, those are going to line up perfectly. So it's also that one. And across the y-axis, here's the y-axis, fold it in half on the y-axis, that would work also. Next one, what is the rotational symmetry for this figure? So let's see, we have 1, 2, 3, 4, 5, 6, 7. Told us it was regular. So 360 divided by 7 is 51.4. So submit that, and then you can feel really good about yourself because you got 100%. Woohoo! So the checkpoint I'm going to leave for you to do. I'm just going to show you that there are 4 problems to do. And so that's pretty awesome. So good luck on that checkpoint. And I hope everything goes well for you. So you can watch those videos again, those attempts again, and get the right answers, and then use that to help you do the checkpoint.